How's it going, everybody? In this video, we're going to take a look at our next topic when it comes to Layer 2 VPN, and that's going to be Vpls with BGP Auto Discovery. So far we've taken a look at doing a bunch of manual setups on iOS and XR, and we've taken a look at E-LAN, we've taken a look at E-Tree with a hub and spoke design and full mesh. All that's cool, right? Well, the common denominator between all those things was we had to manually define who we were going to peer with. Where in BGP Auto Discovery, we don't define that. Rather, we go and rely on BGP to figure out who we're going to peer with, and then we let BGP figure out who's doing what and automatically create the pseudo-wires for us, which is nice because then you're no longer having to go out and configure the peerings directly, where our topology is very, very small. Normally in a large topology, you could have thousands of PE routers, and it just wouldn't be feasible to create pseudo wires that scale that large. You'd have just pages and pages of pseudo wires. BGP Auto Discovery does away with that. We'll take a look at HVPLS or hierarchical VPLS in a different video, which even makes BGP Auto Discovery even more scalable. But for right now, we're going to focus on BGP Auto Discovery with LDP Signaling. So LDP is going to be the mechanism that advertises the labels and gets everybody talking to each other and stuff like that. We're going to talk about the PE side of the house first, and then we're going to talk about the Rot Reflectors. So we're going to have CSR2 and XR18 as the BGP Layer 2 VPN Rot Reflectors in this design, and we're going to peer CSR 1, 3, 5, and 7 to CSR 2 and 18. We'll focus on the iOS portion first, and then we'll focus on XR once we get all of the normal configurations up and running, because there's going to be some specifics with XR that we had to take a look at regarding the malformation packets and BGP issues that we could run into. So that's going to be basically what we go knock out in this video. So it's going to take us a little while to get through the config. And we're going to be looking at a lot of debugs and a lot of output. So it's going to take us a bit to get through it. I'm not in any big rush, but we have to take the steps we need to go through in order to get this working. So let's go ahead and start diving into the config. So we're going to be using Service Instance 1000 for BGP Auto Discovery and going from there. The config is actually very, very straightforward. It's not hard at all to get it up and running. It's just one of those things as you begin the configuration aspect of things. You go through, you do the few steps that you need to get it running, and then you're in good shape. We're also going to be taking a look at both variations of the VFI. So we'll take a look at the VFI context, and we'll take a look at VFI Auto Discovery, so the older construct first. So we're going to start on that on CSR1 first. So we're going to come on to CSR1, we're going to go to global config, and we're going to type in the service instance first. So we need to go down to interface gig 3 service instance 1000 Ethernet encapsulation.1q, and we're going to specify 1000. So we're good to go there. And then we're going to come underneath the L2VPN, L2 VFI, and we're going to call this BGP AD Auto Discovery. And then underneath here, we specify the VPN ID. So VPN ID, in this case here, will be 1000. And then we're going to specify the bridge domain of 1000. Actually, I need to go underneath interface gig 3 service instance 1000 Ethernet and bridge domain of 1000. So that's pretty much it. Now, that's the initial configuration, right? Very, very simple. We don't have to configure anything beyond that in terms of the pseudo wires, because remember, BGP is going to do that for us. What I will do is a debug BGP, and we're going to say L2VPN, VPLS, and we're going to say updates, and that's going to be what we take a look at. And we're also going to debug, and we're going to say L2VPN, VFI, and event. So we're going to take a look at a couple of different variations of how this works. Now I'm going to use the rest of the config On 3, 4, and 5 is going to be using the older, or I should say the newer VFI context. So on 3, we're going to do the same thing. So interface gig 6, service instance 1000 Ethernet, and then encapsulation .1Q 1000, and we're going to jump out of here, and then we're going to type in the L2VFI, and we're going to say here it's going to be BGP AD and context, and then BGP AD, and we're going to specify a VPN ID of 1000, and we're going to type in Auto Discovery BGP, and then we're going to say the signaling protocol to use is going to be LDP. Okay. Now underneath here we have a bunch of options that are available to us. We're going to say auto route target for right now because we're not worried about E-tree, where we want to protect or determine which PE routers are going to be able to talk to each other, just like we did with the manual site-to-site pseudo wires when we did E-tree earlier. This one here, we could define that, but we're going to focus on the easy stuff first and then get into the more advanced stuff later on. So we're doing a full mesh here. We have that in play. So now that we have that, we're in good shape. And now we get to go over to the bridge domain. So bridge-domain, we're typing 1000. And we're going to, underneath here, we're going to type in member is going to be service instance, member gig, this case here would be gig 6, service instance 1000. Pretty simple stuff. And we're going to say member VFI BGP AD, and that's pretty much all we have to worry about. You'll look underneath here that there's not a whole lot more for me to really worry about in terms of operations, but that's basically where we are. So I'm going to go ahead and go to CSR5 and continue this process. And configuration wise, as you can see, it's not too terribly difficult in order to get this stuff working. It's just you definitely have to know the steps. So we're going to type in interface gig 3, and we're going to say service instance 1000 Ethernet, encapsulation .1Q 1000. And then we're going to specify L2VPN VFI context is BGP AD, and then the VPN ID of 1000. And then we're going to say BGP Auto Discovery, BGP Signaling LDP, and then auto route target. And then we're going to jump underneath the bridge-domain 1000 member VFI BGP AD, and then member VFI, member gig 3 service instance 1000. Okay, now that we have that, last but certainly not least, we're going to come over here to CSR7, interface gig 3 service instance 1000, or Ethernet, encapsulation .1Q 1000. We're going to exit out of there. L2VFI context BGP AD, VPN ID 1000, and then auto discovery BGP signaling is LDP, auto route target, and bridge-domain 1000, and member gig 3 service instance 1000, member VFI and BGP AD. All right, now that we have all that in play, the next step for us to go do is to go configure Rot Reflectors. So normally I would do this on the PE side first, and then as the Rot Reflectors come online, it'll automatically spin stuff up. But I want to go do this on the Rot Reflector side first, so that when we start kicking off the config on the PE side, it'll be, we can focus on looking at a single connection, and then we'll do CSR1 and CSR3, and then we'll see the connections come online and how all that stuff ties together. So we're going to go to CSR2, and I'm going to go to global config, and it's going to be router BGP1, no BGP default IPv4. We're going to type in neighbor, and I'm going to type in IBGP peer group. And underneath here, we're going to type in remote AS of 1. The update source is going to be loopback 0. Then I'm going to come in here and type in neighbor of 10.0.0.1, peer group of IBGP. And do the same thing for 3, 5, and 7. And I'm going to type in address family, L2VPN, and then we need to specify Vpls. And then we're going to come underneath here, we're going to type in, neighbor IBGP Rot Reflector client. And then we're going to specify neighbor of 10.0.0.1 activate. And if we do show run section BGP, what's cool about doing that is it automatically associates Rot Reflector client to these specific neighbors. So then all I got to do is do 3 and then 5 and then 7, like so. All right, now that we've got that in play, now I can go back to my PE routers and configure them. So I'm also going to come over here to CSR2, and we're going to do a debug BGP L2VPN Vpls, and we're going to type in updates because we're going to get a lot of information. On CSR1, I'm going to go to global config, router BGP1, no BGP default IPv4, neighbor of 10.0.0.2, remote AS of 1. The update source is going to be loopback 0. Address family is going to be L2VPN Vpls, and we're going to go ahead and we're going to activate the peering. Now you can see that we have some route target information coming in and all that good stuff that goes along with that. So we have the peering is up, and then you'll see that, so let me go ahead and scoot this over just a little bit more and so I can stretch out this console window just a bit more so you guys can see it better. So basically the first thing we get, we see an NLRI update and export community count. So we have a route target of 1000. So basically all this means is we have the autonomous system number and then the VPN ID are basically collected, and that's basically how we determine the route target value. So we can determine this more, or we can get into specific route target values, but that'll be down the road when we get into E-Tree. We have the AGI. The AGI is going to be our that's going to be like the binding agent, if you will. We'll talk about that here in just a minute. But as you can see, we're seeing a lot of information going back and forth. And what we need to do now is on CSR1, do show run section BGP. I'm literally going to take this config and I'm going to dump it onto CSR3. So I'm going to go to CSR3, I'm going to right click and paste. And it's going to take a couple of seconds for it to do its thing. But once it does, what we should get is a connection to CSR1. So that'll take a couple seconds for it to do its thing. So if we were to do a show BGP L2VPN Vpls all, we have a connection to router 1. We have our connection up, and if we do a summary, we have an active connection, right? All right, it took it a couple of seconds for it to trigger, but we finally have some activity going here on this side, which is good. So now we have the VC ID is good, so we're going to come in here and, let's go to CSR3, show BGP L2VPN Vpls all. We can see a connection from router 1, which is good. And if we look at the output of this information, if we come up here and we look at this right here, I believe I have to grab all of it. Let's look at, sorry, it's the, there's specific data I need to look at. So we're going to grab, let's look at 1.1 here. So as you can see, there's a ton of data that's coming back and forth. We see the route target value, the AGI, and stuff like that. So the AGI is going to be the attachment group identifier, which is basically allows the PE routers to communicate with one another. So we see that coming up, and everything looks pretty good in that respect. So we have that squared away. If we do a show MPLS forwarding table, we can see that we have several layer 2 circuits coming in, which is what we want to see, which is a great thing to see. Now we're going to take the config again, show run section L2VPN, or I'm sorry, section BGP, and we're going to start adding this, growing this. Okay, we're going to go to CSR5 and basically do the same thing. We're going to dump this on here and then CSR7. It becomes pretty straightforward as to how the config goes together. If we go to CSR2, we're going to see a bunch of stuff coming in. We're going to see stuff coming from router 1 and from router 3. If I show BGP L2, let's actually go to config T line console 0, logging synchronous. We'll do a show BGP L2VPN VPLS all. And as time goes on, we'll see stuff coming in. They might be wondering why you see a /96. This is because you have the 90 or 64 bits for, or basically the 8 bytes for the route target, and then you have the 32-bit address for these for the PE that's originating this information. So now if we go back to CSR1 and I come in here and I do a show bridge dash domain for 1000, right? We have a lot of bridge domains going on. So right now nothing's really happening. And the reason why we don't have anything really happening is because of the fact that they can the attachment circuits, those connections down to the CE side aren't set up yet. They haven't been configured to communicate with one another. So let's go ahead and do that. We'll go to router 1. We're going to go to interface gig 0/0.1000, encapsulation.1q 1000. I'm going to choose IP address of 10.1.1. We'll use 100.100.1/24. And then we're going to go over to, on CSR1, if we do a show bridge dash domain 1000, you'll start to see stuff coming in from the local attachment circuit. So we'll go over to CSR for router 3 and do the same thing. We're going to go to interface, or sorry, on interface gig 2.1000, encapsulation.1q1000, IP address of 10.100.100.3/24. And we go back to CSR1 and we hit the up arrow, we're going to start to see it automatically propagate this, and you can see BGP AD. That's a good sign. That means that the communication between the PE routers is working the way we need it to. Now we're going to jump down to R4 and do the same thing for him. So interface gig 0/0.1000, encapsulation.1q1000, and then 10.100.100.4/24. Go back to CSR1 and we can see the propagation coming in. So we know that that's working the way that it needs to. And lastly, certainly not least, same thing on router 5. Interface gig 0/0.1000, encapsulation.1q1000, IP address of 10.100.100.5/24. And going back to CSR1, there we have our third MAC address propagated. So you can see that the pseudo wire IDs are coming in, but they are 1,004,023. So we're going to do a show L2VPN Atom VC and hit the enter key. We're going to see a number of circuits coming in. If we look specifically at the, it's not going to show me what I'm looking for. If we do a show MPLS L2 transport VC and we look at this, this one doesn't really give us a whole lot. This other, so we can see BGP AD coming through. So if we were to do a, it's not going to let me see what I want. Show L2 transport, L2VPN, VFI, name is going to be BGP_AD. We can see that the pseudo wires are up and running and everything's looking pretty good, right? So as far as we're concerned, everything's operational. Let's go back to R1 and let's do a ping to 10.100.100.3. We should be able to ping it. We can. We should be able to ping 4. And we can. We should be able to ping 5. And we can, which is great. So which means end-to-end connectivity is working the way that it should be. So we go back to the bridge domain. Nothing's really changed, right? We just resynchronize the time. So this would be the time and point where you would throw a dynamic routing protocol to keep those timer values high, or in this case here, not aging out, so that you can keep this configuration up and running. So if we were to look at the show BGP L2VPN VPLS all, we have there's not a whole lot here that is any different than what you normally would see. And if we were to look at, now we can see a bunch of connections coming in. If we were to look at, say, this one right here, we can see that the AGI value coming in, if we were to look at there's no VEID or virtual endpoint. No, there's no BGP signaling information coming across yet, or we haven't gotten quite to that point. But the configuration that we've got, so you'll notice right here that we have this really high value for the label values. If we did a show MPLS forwarding table, come down here, we have 13, 14, and 15. If we go back to what we were looking at here just a moment ago, we're going to see 14, 15, and 16, right? So what we need to do is we need to come in and show L2VPN Atom, or I should say signal. That's BGP signaling. We need to look at the service VFI interface or peer. Look at all. So we're going to see who we're peered to. So we see 13 comes in, but if we look at the connectivity and we look at detail output, it's going to give us the local labels that are being used: 59, 54, 58, 53, 47, 49, right? It's a core pseudo wire. So all that information that's coming across, we see it being propagated. Now, what I have now is, now that I can look at this information right here, and I have a pseudo wire ID. Now I can come back up here to this and look at Atom and look at VC and detail, and look. It's going to be too much information to parse through. But if I look here through a show MPLS L2 transport VC, and I look at a pseudo wire ID, I can take this value right here. That's way at the top. I was naughty. I didn't do things correctly. Let's look at all. Come down to here, and then grab this pseudo wire ID right there. Actually, let me just put this in here and we'll get rid of this, the PW. It's, maybe I need that. Pseudo wire ID. Okay, so it's a little interesting, but you're going to notice that it's, I'm trying to remember exactly how to do the detail look at it. So if we were to come back to this output right here, VC, that's a pseudo wire ID. I need a, let's see here, VFI, no, I want VFI neighbor 10.0.0.7 and the VC ID of 1000. Oh, that's, and then Mac static. Yeah, see, it's the outputs I'm looking for, trying to find a good one to show you what I'm talking about, but Atom VC. So I have a pseudo wire ID of the interface, so that's actually what I'm looking for. L2 Atom VC pseudo wire. That's not giving me the information that I'm looking for. Pseudo wire. I was just looking at it. MPLS L2 transport VC interface. There we go. That's what I was looking for. A lot of different commands you can throw at this. Pseudo wire interface for 5. Interface. Oh, well, that's not what I was looking for. Let's see, VCID. Can I just look at it this way? No. What about? See, the problem is that I'm running into is that these pseudo wires are dynamically created by BGP, and then the LDP signaling comes into play. So there's no real good way to break this down. Actually, if I was to control U on this line, let me go ahead and get out of the way again. So what I'm looking for is the show L2VPN Atom VC VPLS. Did I throw a VPLS ID in there? I don't remember doing that. Oh, we can do 1:1000 and then detail. Here we are. Okay, this is what I was looking for. All right, so if we were to look at this specifically, we're going to see a bunch of information. So this is what I was looking for specifically. So you can see that the connections came up, and we can see the local labels, 2749, and so on and so forth. So this would be how you would validate the actual pseudo wires that were generated dynamically. So as you can see, there's a lot of information here that it's been a while since I've had to dive into it to this level, but this is the detail that you would want to know. Now, one of the things that I'm going to flip over to now that you've seen this, because this is going to be the norm. Before we've manually configured the pseudo wire, now we're letting it be dynamically created. This is the first time we've relied on a dynamic creation of a pseudo wire. Everything else has been we're pointing to who we want to peer to and defining the actual virtual circuit ID. Here, we're letting something else create it for us, and we have to go through the verification steps are a little bit different. So what I'm going to do now that we've gone through this is we're going to go and configure CSR 1, 3, 5, and 7 to peer to XR 18 and get him squared away. So router BGP 1, and then we're going to type in neighbor of 10.0.0.18, remote AS of 1. The update source is going to be loopback 0, address family L2VPN VPLS, and we're going to go ahead and we're going to activate that peering. So do show history. We're going to take these few lines of config. We're going to drop it on all of the PE routers. And there's a reason why I'm doing this now. And go to 5. And then 7. So one of the things that we're going to run into a problem here is the configuration on the PE side is going to be a little goofy. So we're going to introduce a problem to the network. I'm going to show you guys how to solve it. So on XR18, we're going to go to him, and we're going to go log in. We're going to go to global config, router BGP 1, address family L2VPN VPLS, and we're going to say that neighbor of 10.0.0.1, remote AS of 1, update dash source is loopback 0, address family L2VPN VPLS, Rot Reflector client, and we're going to do a show config. I'm literally going to copy all this syntax right here, and we're going to do the same thing for 3 and 5 and then 7, and then we're going to do a quick show config. Alright, so what's going to end up happening here in just a moment is we're going to commit this config, right? What's going to end up happening is we're going to start getting errors on CSR 1, 5, 1, 3, 5, and 7. And the error that pops up is going to be, let me see if I can't find it for you real quick. We're going to get a and it's not very specific either. I'm looking for a illegal network right here. This is what I'm looking for. So what this basically is saying, it's an illegal network. The easiest way to describe this is normally when you form a peering on any other address family with BGP on iOS XR or iOS, the prefix length is 8 bits, or a prefix length of 1. So when you do this on XR, and I haven't really found any good documentation, there is some RFC 4761 defines BGP signaling or Vpls BGP, and 4762 specifies LDP signaling for BGP Auto Discovery with LDP signaling. And one of the problems you see is on XR, when you turn this feature on, the XR platform will automatically set the prefix length to a set of 2. Now, I haven't really come across any really good documentation, but there is a workaround on the PE side that we're going to go through and do. So what we're going to have to do is on CSR1 is, in order for this to work, we actually have to go into here, and we have to type in the neighbor of 10.0.0.18, and we have to say prefix length size is 2. Okay, that will fix our problem, and that will cause the sync up to work the way that it needs to. So I'm going to go ahead and do show history, and I'm going to grab this line of config here and drop it on CSR 3, 5, and 7 respectively. So that should bring up all of our connections to XR18, which you can see XR18 now is starting to bring these connections up. And now if we go back to CSR1 and do a show BGP L2VPN VPLS all, we're going to see stuff coming through, and we can see equal, we have two different peerings, right? We have high availability between them. So we could do some manipulation here if we wanted to. If we were doing something like Intra autonomous system layer 2 VPN, which we will be taking a look at in another set of videos, but for right now, this is where we're at. So if we look at XR18, for example, and we do a show BGP L2 VPLS, and we do a summary, for example, we're going to see this information coming across. If we look at this, we can see that there's no label here. That's okay. One of the things that's interesting about this config is we actually have to do something a little bit unique. So show run router BGP. What we have to do is on each neighbor, we actually have to go and turn off BGP signaling. So we have to turn BGP signaling off in order for this to work. So we're going to type in router BGP1, and we're going to type in neighbor of 10.0.0.1, and underneath address family L2VPN VPLS, we're going to type in signaling BGP disabled. It's basically a negative logic. So if we do a show config, we're going to take this couple lines of config, and we're going to go back over and go to 3 and copy paste, 5, copy paste, and then 7, copy paste. And then we're going to go ahead and commit. And that will turn BGP signaling off, and we're going to go to LDP signaling instead. So now if I go back to that one line we were looking at before, you'll notice that not a whole lot has changed, right? If we look at this, we can see that we still have connections up and everything's working the way that it needs to be. The bigger thing is, can I ping 10.100.100.3? Yes. Can I ping 4? Yes. Can I ping 5? Yes. I mean, that's really all you care about at the end of the day. But you have to remember the VPLS specifics on XR. You have to turn off enable prefix link size 2 on the PE side, and then you have to turn BGP signaling off on XR, because it'll do it by default. So just keep those things in mind. That is VPLS BGP Auto Discovery with LDP signaling on iOS and XR. That's pretty much all there really is to it. So with that being said, ladies and gentlemen, thank you for hanging out with me and watching this video, and we'll catch you guys in the next video.